After this lesson, we are going to be able to identify what an index is, simplify radicals with different indices, use absolute value when simplifying radicals, and rationalize any denominator, which means if a denominator has a radical, fix it. No radicals on the bottom. So let's talk about when do we use absolute value. So we use the absolute value symbol when our index, which is right here, when our index is even, and the variable comes out and it has an odd exponent. So if it has an odd exponent and the index was even, boom, absolute value. Okay, so let's just review what it means to have an index. So like if I knew that 5 squared was 25, so when I would take the square root of 25, I would get 5. So basically this guy right here. Now you can see how there's no index. And so when there's no index, there's a 2. So this basically says I need 2 of the same thing to come out. Well, we know that 5 squared is 5 times 5. So that's basically 2 of the same thing, right? So when we're looking at this, we know 5 cubed is 125. So if we use the cube root of 125, we would be basically taking the cube root of 5 times 5 times 5. And so we would have 3 5s, so 1 would come out. So it basically says have this many of the same thing. So again, 5 to the 4th power is 625. So when we see a 625 in here, we're essentially seeing the 4th root, and then we have 5 times 5 times 5 times 5. And when we have 4 of them, 1 comes out. And so that's why it's just 5. Okay, so that's just a little bit of review about that. But when we're talking in this green box, we don't have any variables, right? So we just have to be more mindful, like it says in the red star, that we're looking for an even index and taking an odd thing out. So if we were looking through our examples, this guy has an odd index, so this would be no absolute value, right? This one has an odd index, no absolute value, right? This one has an odd index, no absolute value, right? But these, right, this guy, this guy, this guy, this guy, nope, that's it. So all of those three, those all have even index, right? Because if there's nothing there, there's a 2. So you have to kind of remember that in your head. Okay. So if it's odd, like the yellow ones, there's no absolute value. If it's even, right? So odd, no absolute value. Even, we have a possibility. Possible, absolute value. And those are all the pink guys, right? Oops. All right, here we go. So we look at the first one, and it says the index is 3, which means if I have 3 of the same thing, 1 has to come out. Now you do not have to do this. I'm just showing you. Remember, x to the 4th is x multiplied by itself 4 times, and y to the 6th is y multiplied by itself 6 times. So what we're basically looking for is 3 of the same thing. So 3 of the same thing, and x comes out. 3 of the same thing, a y comes out, and we're multiplying these. 3 of the same thing, a y comes out. And because the index is odd, we don't put absolute values, but we're going to keep the index because we do have one of these left over. So we clean this up, and this is x, right? And then we have y squared because we had 2 of the y's. And then we have the cube root of x, and that would be our answer. Okay, let's look at the next one. The next one, we do have that even index. So we're going to be mindful of taking an odd exponent out. Okay, so again, you don't have to do this part, but I'm going to actually just show you this whole thing broken down. So we know 16 is 4 times 4, and 4 is made into 2 2's. So the 16 is essentially this. And then we have x to the 5th. You guys, don't do this. I just want you to see it so that you can do this in your mind. And then you can see how the more we have in our exponent, the more of a pain, 1, 2, 3, 1, 2, 3, it is to do this like this. Okay, so we have 4 things to take 1 out. Well, that means we can take a 2 out. Well, we know a 2 is positive. Even though the 2 has a 1 as an exponent, we don't have to put an absolute value because 2 is positive. So you don't put an absolute value on the numbers because we can see what they are. We have to put an absolute value on the variables because, you guys, we're not sure if we have a positive x times a positive x or a negative x times a negative x. And I'll kind of get into that in a minute. But we can see how we have 4 of these with 1 left over. But when we take this out, this guy has a 1 on it. Now that's a variable. So we have an even index and a variable with an odd exponent. So we'll put an absolute value. And then the next one, we're looking for 4s. So we have 1. We have 2 with 1 left over. So this guy would have an even index, so we would not put an absolute value. And then we'll put our leftovers, remembering to keep our index on there. So we had an x left over and a y left over. So this would be our answer. Excuse me. So our next one, we can see that we do have a variable that, we do have an radical on the bottom, and our radical has an index of 2, which means we need, in order not to have a radical, we need to take everything out. And right now, when we look at an 8 is a 2 times 4, and that means we have 3 2's in there. Well, we already talked about this. When we have no exponent, there's a 2, so I need groups of 2. So right now we have a 3 staying on the top, we have a 2 coming out, and a 2 left inside. Well, that means we have a radical on the bottom. And because our radical has an index of 2, that means I need to have 2 of these underneath. Well, in order to do that, I'm going to need to multiply the bottom by 1 more. And it has to have the same index, otherwise it won't work. So essentially this is what it would look like, right? And then on the bottom we have 2, and then inside we have a 2 times 2 now. Well, you can see now that we have a pair of 2's, so this 2 comes out and multiplies by that 2. So we'll end up with 3 radical 2, and then on the bottom 2 times 2, which is 4, and we're done. And when we simplify, remember we have to do outside with outside, inside with inside. So when we look at our outsides, there's nothing in common, and we only have something on the inside on the top, so we're finished. Again, we had an even index, but we had only values, not variables, so no absolute value needed. Okay, so like we said, no index means an even index. So we can see how we have a lot going on inside. So what we're going to do is we're going to clean the inside of the house up first. We're going to look at that fraction and see if there's anything in common. Well, with the numbers, we can see that there's a 2 in common. So now we would have a 3 on the top only. And with the variables, we have 1 on the top and 4 on the bottom. So we have 3 more on the bottom. Okay, so we've cleaned up the inside of the house. Now we're going to take this fraction that's in a radical and break it up. So we'll do a top and a bottom. You can never leave a fraction in a radical because as you can see, we will have a radical on the bottom basically. So let's take everything out that we can. Well, right now we have the square root of 3, and then on the bottom we have the square root of x times x times x. Okay. No index means that it's even a 2, right? So this would be an x coming out, but it's odd, right? So that's an absolute value, and an x staying in, and then radical 3. Okay. So we're not allowed to have a radical on the bottom, and it has an index of 2, so we need 1 more. So we use the same index, and we get 1 more, and we multiply by the top and the bottom. So on the top, we'll end up with a 3x. But the bottom, we're going to end up with the absolute value of x, right? Making sure that's positive. And then we have x times x, which means an x is going to come out. When I take an x out, that means I'm going to have x squared now. Well, anytime we square something, it stays positive. So that's why we never need an absolute value when we have an even exponent. And so we are finished. Because this x is inside and these x's are outside, we are not going to be able to simplify. Okay, let's just move this over because I kind of was on a slant there. Okay. Now this one's kind of interesting because although there's no variables, we do have a number that is kind of a little bit hokey. It's a decimal, right? Well, this decimal has 1, 2, 3 spaces, right? So that means when I break it down, I have to split these 3 decimal places up. So let me give you an example. I know 27 is 9 times 3. So I can either give 2 decimal places to this one and 1 decimal place to that one, or vice versa. Now, I'm not going to suggest that you guys do this separating of the decimals until you have broken it all the way down. So as you see, once we break it all the way down, we will end up with a 3 times 3 times 3. Well, guys, we said 1, 2, 3 decimal places. So we'll give 1 decimal place to this guy, 1 decimal place to this guy, and 1 decimal place to this guy. Well, that works out in our favor because our index is 3, so I need 3 of the same thing. And so I do have 3 of the same thing. And the thing that I have is 0.3. So 0.3 would be our answer. Everything comes out of that radical because the index was 3, and we had 3 of the 0.3s. So let's just take a little bit more of a side note on this. Let's do one more of those. Let's say that I had 0.0, 0.016. Okay, and we have to the 4th power. So now I need 4 of the same things. But you can see I have 4 decimal places. So if I can find something that's the same, I can give each one of them a decimal place. Well, we already talked about 16 and how 16 is 2 times 2 times 2 times 2. Well, we're going to do is we're going to take these decimal places and we're going to give 1 to each of these. So we're going to give 1 to each of these, which means what comes out is going to be a 0.2. So this is an extra example if you need it. Okay, so let's look at the next one. Now we see that we have a radical on the bottom. Now we could just say, oh, I need 3 of these, and then we would go 4x, because we need 2 more, right? But we would be kind of blowing this problem up, and let me tell you why. Because in order to do that, we would say that 4 could not be broken down. So instead of doing that, what we're going to do is we're going to clean the house first. We're going to see if there's anything that can come out. So when we do that, we know that a 4 comes to 2 times 2, and then we have an x. Well, nothing could come out, right? But we did see that the 2 broke down. So I do have 2 2's, which means I only need 1 more. But I still need the 2 x's, right? Because I only have 1 x. But whatever I do to the bottom, I have to do the top. And notice how my index is 3, because I can't combine these radicals unless we have the same index. Okay, so we have 2 on the top. And then on the bottom, we'll be taking a 2 out, and we'll be taking an x. And then we also have 2x squared in the cube root on the top. Well, when we look on the outside, so this is on the outside, and this is on the outside. So on the top and the bottom, we both had a 2 on the outside. So we can simplify those. And so we will be left with just the cube root of 2x squared over x. Now, because these x's are on the inside and this x is on the outside, we can't simplify this anymore. So we are finished. Cool. All right, well, I hope that helped you guys. Take care.